Hello everyone. I want to try something new, which is to introduce some of my blog posts with a little video where I can describe some of the reasons why I did the post and talk a little bit about what's in it. I really enjoy writing about turfgrass, but I know some people would rather listen or watch or hear from me a little bit. You can always find more information from me and see most of my new blog posts when I sometime after I post them. I will share them through a link on Twitter. So if you don't follow me on Twitter already, I'm at Asian Turfgrass there. And you can also always find a lot of information at asianturfgrass.com. And right there on the front page at asianturfgrass.com, you'll see the new blog posts, and you can also see where you can subscribe to the newsletters, and one of the ATC newsletters will give you the full text of every new post on the same day that it is published. So the post I want to introduce now is one that I wrote a few days ago, and that is about how much carbon and humus are in the soil. And this is something that is really interesting. It surprises me how many people are interested in carbon as a fertilizer, which I never really think of carbon as a fertilizer. I think of organic fertilizers and inorganic fertilizers as options to use, but I never really think of a need to apply carbon as a fertilizer. It seems kind of silly to me to think of carbon as a fertilizer because grass is a carbon generating machine. It's capturing carbon dioxide from the atmosphere and then it's storing that carbon in soil organic matter. But there's a particular series of posts on my website that have received a lot of traffic. When people are searching on Google, I can tell that they actually are searching for carbon fertilizer because it turns up and directs them to my website, and they see some of the posts that I've written about this in the past. Now I'll put a link to all of these relevant posts about carbon fertilizer or about adding carbon to feed the microbes in the soil and things like that. I'll put those in the description of this video down below. So I was kind of wondering, because I know there's a lot of carbon in the soil, and so when I wrote this post, I was wondering what happens if we just see the soil organic matter change by one increment. So by an increment, I'm talking here about 1/10%. For example, to go from 1.8% to 1.9% by mass in the soil. And I made some calculations in this post just about how much that would change the soil organic matter. How much that would change the carbon in the soil organic matter. And we can think about this in some units that might actually surprise you, because it certainly has surprised me at just how much carbon there is in the soil. So for example, we can take the area of 1 square meter, and let's go down 4 inches or 10 centimeters. So that's a volume of 100 liters or 10,000, what is that? 100,000 cubic centimeters. And so when we have that volume, then we can look at the bulk density of the soil, which if it has about 1.8% organic matter, the bulk density will be about 1.4 grams per cubic centimeter. So the soil will weigh about 140 kilograms or about 150 kilograms to that depth in 1 square meter. And then we can say, okay, if the soil had only 1% organic matter and the soil itself weighed 140 kilograms, then the amount of organic matter would be 1.4 kilograms in 1 square meter, which, okay, that's a lot. If you think it's just 1 square meter, which is a small amount of soil, you think it's to a 4-inch, 10 centimeter depth, that's also not very deep. And the soil organic matter contains about 58% carbon. So more than half of the soil organic matter, more than half of the humus in the soil already is carbon. So if we just had a root zone to a 10 centimeter depth, and if it had only 1% organic matter, which is relatively low, even for highly managed sand root zone turfgrass soils, that would have 1.4 kilograms of organic matter per square meter, and it would have more than 700 grams, about 1.5 pounds of carbon per square meter. But a more normal value of soil organic matter would be about 1.8%, so we can just about double those numbers. And I was just wondering, in 1 year, what would happen? Because basically we would expect it would be normal in 1 year for a soil to have 1.8% organic matter, and it would be normal to change by something like 0.1%, to go from 1.8% organic matter up to 1.9% organic matter. So that's just a change in soil organic matter of 0.1%. And when I made that calculation, the carbon goes up by 70 grams per square meter, which is 700 kilograms per hectare, which is 14 pounds of carbon per 1,000 square feet. And what is that? 610 pounds per acre. This is a tremendous amount of carbon, and the grasses produce the carbon. They produce it naturally. So I think it's interesting to be familiar with these numbers, and I think it surprises me just how much there is. So I think it makes sense to really manage that. I recommend some specific testing, and by doing this specific testing, you can make sure that you're managing the soil organic matter at just the right level, both to promote healthy grass growth and also to make sure that you're maximizing carbon sequestration in the soil and making sure that you're also maximizing playability and making sure that there's not carbon and organic matter accumulating in the soil too rapidly, accumulating to a degree that you might have trouble managing it sometime, but you wouldn't be seeing that as it develops. So that's kind of what this post was about. And in the description here, I'll put a link, obviously, to this specific post, and I'll also put a link to some of the other posts I've made about carbon. So there's an article by Dr. Caro asking the right questions, where he wrote this back in the 1990s, and it's kind of about whether you should add humic acid or not. And he's just talking about how much humus is produced by turfgrass every year, and the quantity produced by turf is huge. And the question is, why would you add any more? And then a couple of really good articles by David Zuberer about whether you need to add beneficial microbes to the soil to make it function properly, or whether you need to feed the microbes that are already in the soil. And especially related to sand root zones, sports turf root zones. And of course, the big article that everyone likes is by Brian and Tyler Hopkins, and it's called, "Is Carbon the Next Frontier in Fertilization?" And their answer is pretty clearly no, it's not, but it explains why. And of course, carbon is very important, soil organic matter is very important, but grass produces a ton of it. So I suggest for everybody to take advantage of that. So that's kind of my introduction to this blog post. It's what this blog post is about. And again, you'll find plenty more information, as always, at asianturfgrass.com. That's where I write about this and many other interesting turfgrass topics. And I hope you will find this useful, and I hope you'll read some of these links, some of these other posts that I've made about this topic, and I'll be interested to hear from you if you have some more information, if you can correct my math, if I made some mistakes. Sometimes these numbers are so big, I'm like, man, did I really do that right? Is there really that much carbon there? And so this is fascinating. I'm sure I'll get some feedback from this, and we can continue this discussion. All right, thanks so much for your time, and thanks for watching.